International Conference on universal threads in expert application and solutions, or as we fondly call it, UNI-TEAS 2026. I am Aparna, and it's an absolute pleasure for me to be the moderator for this session. This prestigious conference is being organized by Shree University College, Apex University, and Panipat Institute of Engineering and Technology, managed by Consultancy Services India and supported by University of Rajasthan, ACM Jaipur Chapter, All India Council for Technical Education, and Computer Society of India Jaipur Chapter. This year, we received an overwhelming response with over 300 paper submissions from across the globe. After filtering out AI-generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our session chairs, these selected papers will be published by Springer Nature. The day one of the conference, that is 16th of Feb 2026, we had an incredible series of keynotes, paper presentations, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity offline in Jaipur. As we step into day three, we carry forward that same enthusiasm, ready to dive deeper into thought-provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I'm pleased to introduce our session chairs for this segment. Our session chair one is Abhishek Dixit, sir, Associate Professor of JECRC Foundation, Jaipur. Thank you so much, sir. We are happy to have you here. Can you please share some of the opening statement with us?
Yeah, thank you for inviting me as a session chair in this conference. Let me introduce myself. I'm Dr. Abhishek Dixit. I'm Associate Professor in Department of Computer Science Engineering at JECRC, Jaipur. And I have over 16 years of academic and research experience. And my research focuses mainly on the autonomous driving, trajectory prediction, and the driving style recognition using machine learning and deep learning models. So I have published various papers in SCI and Scopus Index journals, as well as I presented many papers in the conferences. I hold several patents also, and I wish you good luck to all the participants and the organizers, and thank you for inviting me as a session chair. Thank you.
Thank you so much, sir. With that, I'll introduce the second session chair for this session, which is Mr. Vijay Gupta, sir, Professor of International School of Informatics and Management, Jaipur. So we welcome you here. Please share some of the opening words with us.
Thank you, Aparna. Thank you for inviting me as a session chair for this prestigious conference. To introduce myself, I am Dr. Vijay Gupta. I am Associate Professor in Department of Computer Science in International School of Informatics and Management. I have the experience of 25 years in teaching, and I have done several papers. I have published several papers in computing, and my research area is mainly data science and software engineering. Thank you. Thank you very much.
Thank you so much, sir. With that, we'll invite a third session chair for this particular session, which is Sonali Vyas, ma'am, who is the Senior Associate Professor of UPES University, Dehradun. Thank you so much, ma'am. We are happy to have you here. Please share some of the opening words with us.
Thank you so much, Aparna. It is really wonderful experience always to be part of TEAS 2026, because it is under the umbrella of KK Consultancy, which is very close to my heart because of Professor Vijay Singh Rathore, sir. He is being my mentor when I was doing my PhD, and it was wonderful connecting on the conferences with such beautiful brains, youngsters. So conference provides these platforms where we can share our ideas through research papers, with collaborations, etc. Because research is something which is not done in a day or in a night. It is a ongoing process. And let me introduce myself first. I'm Dr. Sonali, and I'm working as Senior Associate Professor in UPES. Soon I'll be joining as professor in Jaipur only. I'm not revealing the university, but soon by my LinkedIn profile, everybody will know. And my research area is data science and healthcare. And I did many patents as well, also SCI publications. I have authored 4 books and edited 8 to 9 books. So I believe that whenever you are pouring your knowledge into books, then it helps not only researchers but also many industry experts who are going to work on these projects, as well as scholars, because my main focus area is how to ignite this fire of researching in India among youngsters, because from there only we can sow the seedling, and these seeds will sometime sooner they will give us some fruits. So I can see in the participant list there are many researchers, and I wish you all the luck to present your ideas here. As learning never stops, so act me. I am acting like a learner here, so and full of with curious brain. So I will ask questions also, just to understand your knowledge. So let's begin this session with Professor Vijay and Dr. Abhishek.
Thank you so much, ma'am.
Thank you,
Thank you
ma'am.
so much.
It's wonderful to connect with you guys also.
Yeah, thank you.
Yeah. Thank you so much, sir and ma'am, for that wonderful introduction. So, before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First, each presenter has only 7 minutes to present. Please stay within the time limit. Secondly, briefly cover your research context, objectives, methodology, key findings, and conclusion. Third, a short Q&A session may follow your talk of up to 1 to 2 minutes. Keep the responses brief and focused. Fourth, keep your mic muted when not speaking. And fifth, stay for the full session to support the fellow presenters. And with the kind permission of the session chair, ma'am, sir, shall we begin the paper presentations?
Yeah, sure. Let's begin.
All right. Thank you so much for the confirmation. So with that, I would like to call upon the first paper presentation with the paper title, Sentiment Aware Investing, Analyzing the Models in Generating Sentiment Analysis of Real-Time Stock News with the paper ID 461. I would like to request Mr. Sumit Pundir, sir, if he is here, to please proceed with their presentation. I guess sir is not available right now. So we'll be moving towards the next presentation, which is with the paper title Intelligent Gait Recognition for Smart Prosthetic Control Using Deep Learning with the paper ID 460. I would like to call Mr. Sujan Kataria, sir, to please proceed with the paper presentation. And over to you, sir.
Hi, yes, good afternoon. Good afternoon to everyone in the meeting. I am Sujan Kataria from Manipal University, Jaipur. And today I'll be presenting our work on intelligent gait recognition for smart prosthetic control using deep learning. This work focuses on identifying which neural architecture best generalizes across users under a unified experimental framework. Should I present the presentation?
Yes, sir.
Yeah. Just a moment. All right. So modern smart prosthetics must adapt in real time to a user's locomotion intent, whether they're walking, running, or transitioning between movements. Wearable IMUs provide rich lower limb motion signals, but these are multi-channel time series with noise and high variability across subjects. The key challenge is building a model that is not just accurate, but generalizes across individuals. One issue is existing literature is that many studies evaluate a single model under different pre-processing setups. This makes it difficult to identify which architecture truly performs the best. Our contribution is a unified experimental framework comparing 9 deep learning architectures under identical pre-processing, windowing, training, and evaluation conditions. So performance differences arise from model design alone, not training tricks. We use the HugoDB v2 or the Human Gait database, which is specifically focused on lower limb motion. It includes 10 subjects, 6 IMUs placed on the foot, the shank, and thighs of both legs, producing 18 signal channels, which were sampled at 60 Hz. Importantly, it contains both static and transitional activities, which are very important for prosthetic control. Transitional activities are particularly challenging because motion phases can overlap. For the pre-processing, we segmented signals into 2-second windows with a 50% overlap. Each window becomes an independent training sample. More importantly, we used a cross-subject split, where subjects 1 to 6 were used for training, 7 for validation, and subjects 8 to 10 for testing. This ensured that the model was evaluated completely on unseen individuals, which reflects real prosthetic deployment. So the pipeline is straightforward. The IMU signals are segmented and normalized. They are passed through a deep learning model, and a predicted activity label can drive prosthetic actuation. Since this was meant for embedded control, we must balance the accuracy with computational efficiency. Accuracy alone is not sufficient. So here are the following models that we used. We compared 9 architectures across recurrent, convolutional, hybrid, and attention-based families. The recurrent models include LSTM, bilateral LSTM, and GRU. The convolutional baselines included one-dimensional ResNet and TCN. We also tested a CNN and LSTM hybrid and a compact transformer. All of the models end with a softmax classifier over 10 activity classes. All the models were trained under identical conditions using Adam optimizer, fixed learning rates, early stopping, and class-weighted cross-entropy. We used macro F1 as the primary metric to balance performance across classes. This was done since macro F1 treats rare and frequent activities equally. As you can see from the results, across cross-subject testing on subjects 8 to 10, recurrent and temporal convolutional models showed the strongest consistency. Surprisingly, though, the GRU achieved the best macro F1 score of 0.809 and an accuracy of 0.874. Despite being simpler than LSTM and transformer, the GRU generalized better. Most of the errors in this occurred during transitional activities. For example, sitting down versus standing up, or going up or versus going down. And instead, static postures were recognized more reliably. This was likely due to short window sizes and overlapping motion phrases. So this study demonstrated that compact recurrent models can outperform larger and more complex architectures on moderate-sized IMU datasets. The GRU offers a strong balance between accuracy, efficiency, and deployability. Our future work includes on-device latency evaluation, multimodal fusion with EMG signals possibly, and closed-loop prosthetic testing. Thank you. I welcome any questions.
Thank you so much, sir. With that, we are open to questions now, if there are any.
Yes, Dr. Sujan.
Yes, sir.
From where you have taken the data set?
I found this upon Kaggle.
Okay. Have you compared these data models and find which is better, and what are limitations of these models?
Yes. So as I explained, we compared 9 architectures, and out of all of these, the best one was GRU, even though it was less complex and lighter. When you would expect the transformer model to perform more accurately, this was possibly because the data set wasn't very large. It was a moderate-sized data set.
Okay. Thank you.
Thanks.
Thank you, sir.
So, Sujan, my question is why you did this research and what research gap you find in various other research papers that motivated you to do such research, and what is the novelty that you had given in this research?
So what I noticed was that other papers and other research works usually only worked on one model at a time, and if they've used multiple, they had different pre-processing techniques used on the pre-processing pipelines used on the models. Uh, what I have done is I have provided the same pre-processing and windowing techniques for each model, so each of them are under a unified framework. And that's how I could find out that the GRU performed the best, and it would be this
What is the novelty?
solution
I
that
asked, what is the novelty in this research?
novelty is that uh, we had a unified pipeline, which was unified normalization on the entire data set for each model. Usually, when we are applying different models, people use different pipelines. I have made it common for each.
And why
So
you
this
use
allowed me to
Adam optimizer? There are various other optimizers as well. What make you to use only Adam optimizer? Have you compared different optimizers?
No, we did not. This was just to keep it simpler for the time, but this includes future scope to try out different normalization techniques and optimizers.
Okay.
Thank you so much, sir. Are there any other questions?
I have only one question, Sujan.
Yes, ma'am.
Have you also considered visualizing your comparison?
As in?
Like whenever we compare anything, so we can also present it well if we do some visualization, like creating or coding some visualization charts, just
Yes,
to
actually,
understand more.
I
And
did include those in the paper. I failed to include those in the presentation.
yeah, that's what I was thinking. And okay, once you have done the comparison, so
Yes.
what will be your next step? Like, why you did this comparison?
I did this comparison to find which would be the most efficient, which has the best balance between accuracy and computational efficiency. So eventually, this knowledge can be used to train actual smart prosthetic embedded systems. And we would rather use a lighter model on an embedded system. So the GRU performed the best. So that was what came out of this.
And what is your definition of lightweight model?
It has fewer gating mechanisms. It is simpler than other models like LSTM and CNNs, and especially the transformer, which is for larger time series data sets.
Okay, just go and more research on this part, that how you
Yes.
can make it more lightweight model and what it means. Okay.
Yes.
All the best for your research.
Sorry.
All the best for your research.
Thank you,
Thank you.
ma'am.
Thank you so much, everyone. So with that, we'll be moving towards the next paper with the paper title, Influence of EGR on Research Diesel Engine Fueled with Cerium Oxide Nanoparticles Doped Punaga Biodiesel under the paper ID 534. I would like to call Mr. H. Suresh Babu Rao to please present their presentation if they are here. Uh, I guess he's not here. So with that, we'll be moving towards the next presentation with the paper title, Analyzing the Impact of Basic Text Pre-Processing on Sentiment Classification of Social Media Data with the paper ID 573. I would like to call Mr. Om Singh Bisen to please proceed with the virtual presentation. All the best, sir. Over to you, sir.
Thank you, ma'am. Good mornings, everyone. My name is Om Singh, and I am currently pursuing BCA from MIT University, and I am in third sem of my third year in my college. Ma'am, can I share my PPT?
Yes.
Hello.
Yeah, you can proceed on.
Okay, sir. So let's understand what is sentiment actually is. So people write lot on social medias, reviews, comments, and post, and this is a huge source of data which any company or organizations need for their growth, for their betterment. But the problem is all the text which are present in the social media are messy. It has spelling mistakes, emojis, hashtag, and random symbols. So machine learning's model needs a clean text to work well. So our aim is to show the clean text to improve the accuracy of the model. And so problem statement, whenever we use a raw data directly into the models, so models might be learn a wrong patterns and give a poor result because text is noisy and it's reduce accuracy also. But if we provide a clean text, model can understand better and give a correct predictions. Objectives here we use a preprocessing techniques like lower casing, tokenization, stop word removals, punctuation removals, and we all seen how it's work in the upcoming slide also. We use basically three traditional models: naive Bayes, logistic regressions, and SVM, and then we compared raw raw process performance and the clean text performance methodologies, preprocessing techniques like as we already tell you tokenizations, limitations, stop word removals, feature extraction, TF-IDF, which means providing the numbers to the text. How it's work, I can explain in the upcoming slide also. And then three models, then we train the models, naive Bayes, logistic regression, and SVM, and then evaluate the accuracy by different techniques like accuracy, precision, recall, and F1 scores. This is the techniques we use, lowercasing, like many words in the social media are written in, sometimes it's all in the capitals, sometimes some in small, some in capitals. So it's difficult for the machines to understand, models to understand. So we lowercase for their better outcome. Then tokenizations, we provide a token. Tokenization means is provide a tokens to the different text. Like if anyone comment that this movie is awesome, so it's provide a tokens into different word. So machines can evaluate it easily. Stop word removals, remove the word like the, is, and. This is a not an important word for the sentiment analysis, and it leads reduce accuracy of the model also. So stop word removals helps to improve accuracy. Limitations, liking, it's converted into a like, which also helps in the model accuracy. And then punctuation removals. Feature extractions, after cleaning, we use TF-IDF. It's changed text into the number that I tell you. TF means turn frequency, and IDF means inverse document frequency. How it work? I give you one example. Like if word dragon appears 50 times in a book, so that word is important for that book. That is turn frequency. And inverse frequency is if the word hello appear 100 times in 100 books. So it's not a important words for the sentiment analysis that we seen in the stop word removals, where the is and will remove for the better accuracy. Three model use naive Bayes, which is fast, simple, and provide good baseline. Logistic, easy to understand, good accuracy when we use TF-IDF. And SVM handles complex data, but it needs more computation power if we compare to naive Bayes and logistic regressions. Here was the result. When we use naive Bayes with raw data, the accuracy is 70.2%. But when we use the clean data, the accuracy will increase 78.4%. Here, not only on accuracy, but the precision, recall, and F1 scores is increasing when we clean the text. logistics 70.2 to 78.4%, logistic regression 75.6 to 83.9%, and SVM 78.3 to 86.7%. It's increased continuously when we clean data. So clean data help us models to predict good patterns, right patterns, and provide accurate decisions. Logistic SVM benefit more with the TF-IDF, and SVM is a more benefit models if we compare to logistic and naive Bayes. Naive Bayes fast but slightly less accurate with logistic and SVM. So pre-processing improves sentiment analysis. Even simple models give a good performance when we clean the data. Pre-processing is important than the complex models. Not important for the complex models. Okay. Thank you, sir. If you have any questions.
Thank you so much, sir, for that presentation. With that, we are open to questions now, if there are any.
Hello. Hi, Om.
Hello, ma'am.
I think it is very basic paper or since the initial start of your research.
Yes, ma'am. This is my first paper.
First paper, wonderful. So, what you are planning in future? Like, if you want to research more in this area, then what are your plans?
Ma'am, there was different complex model that I tell you earlier. So after this, I want to compare that models and with the pre-processing techniques and then check the accuracy of that models.
Okay, wonderful.
In in this paper, I only use the traditional models, which is easy for the beginners, like naive-Bayes and logistic regression and SVM. But in futures, I want to do with the some complex models.
When you say complex models, so how you are going to differentiate between simple model and complex models? Can you give me
And
example?
sorry, ma'am.
Can you give me example of complex model?
Ma'am, complex models, there are different models in machine learning. So, like naive-Bayes is fast, simple, but like logistic regression is also fast and simple. But there was a different complex model which not beginner friendly and which is not very benefit for the any beginners to use, and it's difficult to understand also.
Okay. Okay. That's all from me.
Hello.
Hello, sir.
What are the different parameters you have taken in these models?
Sir, parameters. I can't understand what about parameters.
I'm saying when you are going for making the sentimental analysis, you have taken
Yes.
some parameters to compare it.
Yeah,
And
yes, sir.
for naive Bayes, for SVM, for logistic regression, what are
Yes,
these
sir.
parameters you have taken for this?
So, firstly, I collect the data set from the Kaggle. Then then we use the C parameters, which is small c, large c parameters. Then kernel parameters. There were different kernel parameters which are present.
Okay.
So I think Om sir is asking that in the data set, what parameters you have used in the data set that are used for yeah, used in different models for the comparison. So from, you have used the data set from the Kaggle, I think.
Yes, sir.
So
Kaggle
what are the
data set. Yes.
different features or the parameters that are used in those data set?
So some data sets are from different source. Like some data set are from
You
the
have used
Twitter's.
one data set or many other data sets?
Sir, I use the two data sets.
Okay. So Om, actually, you are from BCA third year and you
Yes,
are
sir.
doing research in BCA third year. That's a wonderful thing that I have seen. You are very young to research, and you have done the comparison of various models that already exist. And research is not like something comparison of doing some models. Research is something that you want to put some novelty into your research that has not been done previously by anybody, or
Sure.
adding
But
something into it.
okay.
But you have done wonderful thing as a third year BCA student, and further you can improve a little more. I think you should deep dive into it and learn more about research.
Sure, but the other studies shows the importance of text processing in their paper, but many people don't explain the pre-processing clearly. So in this model, I explained that all how it's helped to beginners to identify the.
So how you have done the pre-processing of the data set? What are the different steps you have taken?
So there were different techniques like lower casings, tokenizations, and stopword removals. Then TF-IDF techniques, turn frequency and invert document frequency.
Okay, good.
Thank you so much, everyone. So with that, we'll be moving towards the paper ID 461 as the presenter is available now with the paper title Sentiment Aware Investing, Analyzing Models in Generating Sentiment Analysis of Real-Time Stock News. With that, I would like to call Ms. Swati Joshi to please come over the virtual stage and present the presentation. Over to you, ma'am.
Is my screen visible?
Yes, ma'am. Ma'am, your mic is muted. Please unmute that.
Everyone, I Swati Joshi from Graphic Era deemed to be university. Today I will present my research paper titled Sentiment Aware Investing Analyzing Models in Generating Sentiment Analysis of Real-Time Stock News. This work focuses on how news sentiment affects stock markets and how AI models can help investors make better decisions, can help investors to make the better decisions. So comes to the introduction. Stock markets today are heavily influenced by news and public sentiment. A single headline can move prices significantly. This research compares traditional sentiment analysis with deep learning approaches. I analyzed 1,000 real news headlines from major companies like Google, Apple, Tesla, and Amazon. The key results in the key result is that the LSTM model achieved the highest accuracy of 87.5%. I also built a real-time tool that analyzes the latest news for investors. So moving on to the problem statement, the stock market is highly volatile and complex. Investors often analyze financial statements but ignore sentiment due to time constraints. Manual and news analysis is slow, biased, and impractical given the huge volume of news. Negative news can crash even strong stock. So there is a clear need for an automated real-time sentiment analysis system. So here are my research objectives. My research had four main objectives: compare traditional and deep learning methods, build a real-time sentiment tool, help investors make better and different decisions, create a user friendly interface for all the investors. So this work is both research oriented and application oriented. Now moving on to the literature review. Past research shows sentiment strongly impacts stock prices. Studies found machine learning usually outperforms lexicon methods. Some hybrid models combine sentiment with time series forecasting. However, many works focuses on only prediction, not real-time usability. My work contributes by comparing multiple models and deploying a Swati, you are not. My project had two parts. The first include web
Swati, your voice is not coming.
the data, 10 companies, 100 headlines each, total 1000 headlines. 80% used for training and 20% is used for the testing. The pre-processing included using VEDA. For traditional models, I used TF-IDF, and for deep learning, I used embeddings and padding. So the models used, I used four approaches. The first one is CentiWordNet plus TF-IDF. This is lexicon-based rule-driven model. The second one is RNN. It is good for sequences but struggles with long dependencies. And the third one is CNN. It captures local text patterns. And the fourth one is the LSTM, advanced RNN, that handles long-term dependencies and avoids vanishing gradients. These models were compared on accuracy and error metrics. Now moving on to the dataset descriptions. So this is my dataset before pre-processing, and this is my dataset after the pre-processing. Now moving on to the tools and the techniques which I have used. These are the tools which I have used. This includes Pandas, NumPy, NLTK, Vedar, Scikit-learn, TensorFlow, Keras, etc. And now moving on to the results and the analysis for the traditional methods. Results clearly favor deep learning. CentiWordNet alone, 77.5% accuracy. And with TF-IDF, I achieved 82.4%. And the third one is for the LSTM, by which I have achieved 87.5 accuracy. CNN had perfect recall, but lower precision. LSTM has the lowest error rates. Training curve shows good convergence and minimal overfitting. So LSTM was selected as the best model. These are the training and the validation curves for the LSTM model. Now moving on to the real-time tool. I built a real-time sentiment tool using Flask. Features of this is fetches latest 100 headlines, runs LSTM analysis, displays results under under 30 seconds. Easy for beginners and experts also. This makes this research practically useful. Now moving on to the conclusions. Deep learning outperforms traditional methods. LSTM is the most effective for news sentiment. The system saves time and reduces bias. It helps investors combine sentiment with financial analysis. So AI can significantly improve investment decision making. Now, moving on to the future enhancement of this research. Future improvements include larger datasets, hyperparameter tuning, hybrid and attention models, integrating price predictions, full investment platform, and mobile app, multi-language supports, and many more. These can make the system more powerful and global. Thank you for listening. I would be happy to take any questions.
Thank you so much, ma'am. With that, we are open to questions now, if there are any.
Swati, you have compared the various machine learning models and you have shown that LSTM is performing better as compared to the various other traditional models. So
Yes,
can you
sir.
tell me the reason that why LSTM is performing better and why LSTM is better than various other models? Am I audible to you?
Yes, sir.
So you mentioned in your presentation that LSTM improves the problem of like RNN, like vanishing
Actually,
gradient, and
LSTM is a special type of RNN designed to learn patterns from sequential data like text, stock prices, and speech signals also. It also solves the problem of vanishing gradient problem.
So did you find that why LSTM is working better than various other models in your case, in your research?
Sir, as it solves the vanishing gradient problem, like in normal RNN, when sequences are too long, earlier information get lost during the training. So
Okay, you
gradient
have
becomes
used
useful.
LSTM directly and you did some hyperparameter tuning as well.
No, sir, directly.
Okay.
So do we have any other questions? Seeing none, we'll proceed further. So now with the paper ID 534, the paper presenter is here under the paper title Influence of EGR on Research Diesel Engine Fueled with Cerium Oxide Nanoparticles Doped Punaga Biodiesel. I would like to request Mr. H. Suresh Babu Rao, sir, to please proceed with the virtual presentation. Over to you, sir. And I would like to request Mr. Om, sir, to please stop sharing their screen.
Yeah. Good afternoon, ma'am. Am I audible?
Yes, sir.
Yeah, just I'm sharing my screens. Madam, unable to share, ma'am.
Sir, there must be an option of screen sharing in
Yeah,
your, yeah, you can try with that.
one second, ma'am.
Sir, you need to press on the upward arrow, and from there you can select continue option to share your screen.
But now if you have his presentation, you can share it from your end as well.
Yes, sir, but I do not have the presentation. But I can request from the organizing team if they can. Please wait a minute for that.
So Rakshan, meanwhile, you try to share your screen in between, like
Yes,
just
sir.
try to click on this share screen and then.
Shall I send to someone, sir? Like,
Yes, sir, you can send on a number I'm sharing you on WhatsApp, and then I'll share the screen.
yeah, please. Can you do that?
Yeah.
If
Uh,
favorable.
Yeah, can you just note down the
What is
number?
the reason it is not for share? Cannot share your screen. Yeah, please. Can you share, please?
Yeah, 9672.
No. Can I share it in group, ma'am? Authors UNI-TEAS 2026.
I'm not in the group, sir, I guess.
Yeah. Okay, then please give your number.
Yeah,
Sorry for the delay.
uh,
Sorry for the delay.
it's okay. 9672
96
9722 83. Yeah, please share in this number.
Yeah, 1 second.
Sir, please confirm once you have
Yeah.
shared the
Yes.
PPT.
Yeah, ma'am. And I suddenly got this problem. Sorry. I'm shared. Please check, ma'am.
All right, sir.
I think you got it, ma'am.
Yes, sir. Sir, that's the number of the organizing team secretary. They'll share with me in 1 minute, and I'll then share the screen itself.
Yeah.
Yes, sir. Now I'm presenting the screen. You can then start with your presentation.
Yeah, I'm ready. Shall I, ma'am?
Yes, sir, you can start.
Yeah. So thank you, ma'am. Good afternoon to everyone. I'm extremely sorry for the technical delay happened. So first of all, good afternoon to dignitaries. This is Dr. Suresh Babu Rao from Chaitanya Bharati Institute of Technology, Praduttur, Andhra Pradesh. I am presenting a paper on influence of EGR, exhaust gas recirculation, on a research diesel engine fueled with cerium oxide nanoparticle doped Punnaga biodiesel. So Punnaga is a biodiesel, right? So next, madam, sorry for because I don't have the option to scroll. Sorry for giving you trouble, ma'am. Yeah. So abstract. So the first thing is the nanoparticles are been exhibiting some extraordinary qualities, which are not having various applications. Where I would like to use this as additives in diesel engine fuels. So here I have used Punnaga biodiesel, which is the chemical name is called as calophyllaminophyllum oil. So these biodiesels were being prepared, and these biodiesels were being blended with different proportions with diesel, and then the cerium oxide nanoparticles were added in different proportions like 30 to 120 ppm concentrations, and which is fueled in research diesel engine. So with this, what is going to happen, and not only the cerium oxide nanoparticle which is influencing the performances, but also the EGR technique is also being implemented so that to control the emissions. Totally, we have taken this biodiesel that is called as Punnaga as 20% with diesel, and remaining is diesel, that is 20% Punnaga and 80% is a diesel. So we have seen that the EGR percentages, that is exhaust gas recirculation, as 0, 10, 20, which resulted is 10% EGR, and out of the best blending is the PU 20 plus 90 ppm blend was successfully seen that lower emissions with a significant little compromise in performance. It given a very good efficient fuel. Right. This is what we have taken as a abstract. Next, ma'am. Next slide, please. I think format is okay. Can you? So the energy crisis. I think one slide is gone, ma'am. Right. Previous slide, ma'am. Okay, no, that is gone. Maybe through parts of it. Okay, next slide, ma'am. Next slide, please. So Punnaga oil, this is nothing but a tree, Punnaga tree, which generally grows in wet and moderate climates, which is highly suitable in coastal areas, which is highly elevated areas, cool areas, very dry conditions it is. So the main characteristics is tree size is 12 to 20 meters, fruit size, seeds. This type of tree doesn't need any type of what you call taking care of anything. It can grow like anything, like as a normal tree. So there is no need of any cultivating standards. Please, next slide, ma'am. So this is regarding the description of tree. Next to what is the advantage of these oils? So it is a multi-purpose use. Not only it is used for biodiesel, this oil can be used for pharmaceutical uses, so wood, etc. The annual yield is very, very important. That is, you can see the annual yield which is been coming. That is a productivity which is shown in the right side, which is shown in the right side. That is nothing but the amount of oil that is being extracted per hectare is highest. So it does not compare with any food crop because it's a non-edible oil, highly survival potential, and withstands drought for 4 to 5 months. It generally grows at coastal areas. So this is the major thing. Right. Next slide, ma'am. So the Punaga oil biodiesel steps of preparation is first one is degumming. You can see on the right side the process is being conducted in the laboratory. Acidic esterification, neutralization, basic transesterification, and then we will go for water washing and heated biodiesel so that the water goes up at 100 degrees centigrade to evaporated, and remaining is going to be the biodiesel which is being blended with the diesel as B20, or you can say biodiesel 20 plus 80% of diesel. Next slide, ma'am. So next step is to synthesis the cerium oxide nanoparticle. For step 1, I have taken ammonium cerium nitrate and sodium hydroxide at 1:4 molar ratio, dissolved completely in deionized water. Then the mixture is stirred well in 100 RPM. So the pH value is checked, maintained to 12 pH. And then later on, it has been kept out in an oven for 50 degrees centigrade for 30 minutes. So you can see the powder, pale yellow powder, which is formed, is result of formation of cerium oxide nanoparticle. This has been experimentally done. Next one. So these nanoparticles are being taken to characterization testing, that is XRD result, and you can see the SEM results, which ensures it is nothing but a cerium oxide nanoparticles with the cubic fluoride structure. Next slide. So engine setup is, as I told, it's a research diesel engine which is present in the laboratory. That is the engine shown, the equipment, and this side engine setup, how we have done. The main part, engine part, we have taken various readings, which is nothing but computerized diesel engine. So all the specifications are given in this. So this is the engine setup. Next slide, ma'am. The main thing is 2 things we are going to take. One is parameter, one is called as performance parameter. Second one is called as emissions parameter. So performance parameters we will look into brake thermal efficiency. Generally, what is going to happen when you put a biodiesel, the diesel has a very good what you call brake thermal efficiency, but B20 is manageable. That is, we can slightly, there is a slightly decrease in it, and we are going to see the nanoparticles that are being inserted in 30, 60, 90, and 120. And along with that, the engine modification done is the EGR, that is exhaust gas recirculated. Exhaust gas is again recirculated in the engine, so that the emissions part we are going to handle up. So in this, we have seen that 90 ppm the biodiesel have shown at 10% of EGR have shown very good brake thermal efficiency, which is near to the diesel. Next slide, no.
So you are left with 1 more minute. Please try to conclude within.
I am completing it. So brake specific fuel consumption. This is nothing but where the brake specific fuel consumption is lower when biodiesel is added. So therefore, means generally it will be higher, right? Lower in the sense that is nothing but higher up. So it is seen that 10% of EGR is slightly having a higher than the diesel. Next slide, ma'am. Next slide is hydrocarbons. So in hydrocarbons, what is going to happen is the more the rise of concentration in EGR, so we can see more of hydrocarbons because unburnting that is going to take place. As EGR percentage is increased, we are going to see more of the unburnt hydrocarbons. So we have come to a compromise of 10% of EGR, which shown a what you call little lower emissions of HCl. Next slide now. Carbon monoxide also is the same case, where we have seen 0, 10, 20, and 30 percentage of EGR. We have seen that the more carbon monoxide reduction has been observed up to 30 ppm. Then later on, up to 120 ppm, it has been raised. Then next slide. So the main important thing is NOx. NOx is having a lesser oxygen because of that higher temperatures that produces more NOx. So in order to handle the NOx, I have used EGR technique. This reduced considerably NOx reduction has happened by using a 10% EGR. Next slide now. Smoke emission is also high. You can see there is a rising of exhaust gases. The smoke also increases, but by putting nanoparticles up to 90 ppm, it went. It is having a considerably good what you call emissions. Smoke emissions have been found. Last slide now. That is conclusion. In this Punnaga biodiesel prepared from transesterification process, cerium oxide nanoparticles have gone through are prepared from the solvothermal method, that is synthesized, I have shown. And cerium oxide is doped with the Punnaga biodiesel with 30, 60, 90, and 120. Out of the experimental research that it has been conducted, it is shown that 10% of EGR with Punnaga 20 plus 90 ppm biodiesel minimally decreased the engine performance and have highly reduced the emissions. This is very important effect from the addition of all these nanoparticles. And best modification is PU, that is Punnaga biodiesel 20 plus 90 ppm plus 10% of EGR engine modification. This is my experimental conclusion. I request any questions from the chairman.
Thank you so much, sir, for the presentation. With that, we are open to questions now, if there are any.
Have you validated your system, Dr.
Yes,
Shree?
ma'am.
Have you validated your system?
System or results?
Yeah, result oriented, very fine. But after validation, you can easily quote it that it is patentable or something like that. What is the main purpose behind this research? How you are going to use it for societal use? Yes, please.
Yeah, mainly. Yeah, please, ma'am. I think should I answer it?
Yeah, please.
Yeah, ma'am. Mainly, thank you for your question, ma'am. First of all, mainly we have many engines which are still working. We have not yet seen EV technologies which are coming up, but still there are many emissions which are coming out from the exhaust gases. As exhaust gases, you can see Delhi problem. Like NOx emission is a basic problem. So by EGR, we can reduce drastically NOx emission so that the smog problem can be reduced. So this is one of my major effort towards reduction of smog by reducing this NOx.
Okay, I got it.
By EGR technique, ma'am. And mainly one small point I would like to add. So nanoparticles usage. This is one of the very important way which I have seen. The nanoparticles have shown chemically they have very immense property of reducing these emissions. So which is even they are not harmful, madam. Even while they are coming out of emissions, they are not also harmful. and the emissions are being get reduced. So instead of going all these very difficult things, we can go with these kind of technologies, and we can add these nanoparticles, and we can develop such a techniques so that we can reduce the emissions. At least the engines, traditional engines will complete. And we also have various emissions problems in various other cities like Delhi and even Hyderabad or in Bangalore. So we can go with these kind of techniques, ma'am.
Wonderful, wonderful, nice.
Yeah.
All the best for this, and I hope you will achieve your objective of the research.
Thank you
Thank
so
you.
much. Thank you.
Thank you so much, ma'am and sir. Are there any other questions? Seeing none, we come to the end of this session. We sincerely thank all our paper presenters for their valuable contribution and all the audience for their active participation, and a special thanks to all the session chairs for guiding this discussion with clarity and depth. And now I would like to call upon our session chairs one by one to please share some of the closing remarks with us. And we'll be starting off with Mr. Abhishek Dixit, sir.
So yeah, thank you. It's been nice to be a part of this conference as a session chair. And the researchers have presented wonderful research. And it's been a good time to learn new things as well as ask so many questions. And good to see my co-session chairs, Sonali ma'am and Vijay sir. And it's good to connect with you because we are meeting for the first time, I think, virtually.
Yeah.
And I think if anybody found anything related to autonomous vehicles or anything like machine learning or AI, so you can connect with me directly. My email ID is abhishekdixit2606@gmail.com. You can just drop me an email, and we can have do some collaborative research or any patent if anyone have any idea related to autonomous or machine learning or deep learning. Thank you so much.
Thank you so much, sir, for such a nice word. With that, we'll be moving towards the next session chair, which is Vijay Gupta, sir. Please proceed with some of the closing remarks for this session.
Thank you very much. It is really a wonderful session. In this session, we had gone through some of the researchers, like the last presentation the Suresh sir has given about the emission of the gases and how we can change the diesel engines. It is really good. Besides this, we have some sentimental analysis papers also there. We have gone through the new things in each of the conference, in each of the session pairs. So I think it is really good to see all the researchers, and thank you very much.
Thank you so much, sir. With that, I'll be calling upon the last session chair for this particular session. So, Sonali Vyas, ma'am, please proceed with some of the closing remarks with us.
Thank you so much. It was really well organized session. So congrats to Aparna for that. She has beautifully handled everything here. Like Dr. Suresh was facing issues with screen sharing, and she handled it really well. So wonderful, Aparna. And also congratulations to all the participants. It was nice session. They presented their ideas, and I have seen that few of you are at initial stages of your research. So you are going well in right direction. But again, always listen to your mentors, because they are the one who will show you path, and you have to walk on that path with your knowledge. So we are there. You can connect with us. Like Dr. Abhishek said, if you are going to do anything in autonomous vehicles, you can connect with him. I am in data science and smart health systems, so you can connect with me, and Professor Vijay is also there. We all are on LinkedIn, so we can connect and collaborate, because once we collaborate and connect, then only research can turn into beautiful results. And as Dr. Suresh idea is really very well, and he has also started from a small little bit of thinking, which Om and Sujan and other people presented as they are having initial ideas in their mind. So keep on researching, keep on sharing your knowledge with one another, and stop not till you achieve your goals. That's what I want to say and conclude the session on my behalf. Thank you everyone for patient listening, for sharing ideas. Thank you so much. And
Thank you
congratulations
so
to
much, ma'am.
organizers.
Thank you so much, ma'am. With that, now I would like to request all the participants here to please switch on the camera so that we can have a virtual photograph to capture this memorable session. All right. Thank you so much, everyone. And with that, best luck and wishes to everyone for the future work and have a great day ahead. Now you can leave this meeting.
Thank you.
Thank you.
Thank you.